Have you ever wondered what would happen if our sun, the life giver of Earth, suddenly turned into one of the most mysterious and extreme objects in the universe? I'm talking about a neutron star. Buckle up, because today we're diving into this wild hypothetical scenario. What exactly is a neutron star? What would happen to Earth, the other planets, and life as we know it? And could we somehow survive? Let's find out. What is a neutron star? First, let's break it down. What exactly is a neutron star? Picture this. A massive star, much bigger than our sun, runs out of fuel to burn. Without the energy to counteract gravity, it collapses in on itself in a violent supernova explosion. What's left is a neutron star, one of the densest objects in the universe. How dense, you ask? A neutron star crams more mass than our entire sun into a sphere only about 20 kilometers across. To put that in perspective, it's like compressing the mass of Mount Everest into a sugar cube. 1 teaspoon of neutron star material would weigh around 4 billion tons. That's the weight of about 13,000 Empire State Buildings. And they're not just dense, they're fast. Some neutron stars, called pulsars, spin hundreds of times per second. They also have insanely strong magnetic fields, trillions of times stronger than Earth's magnetic field. Can our sun turn into a neutron star? Here's the catch. Our sun cannot naturally turn into a neutron star. Why? It's just not massive enough. For a star to become a neutron star, it needs to be at least 8 to 10 times more massive than our sun. So what will our sun do instead? Billions of years from now, it'll expand into a red giant, shed its outer layers, and eventually settle down as a white dwarf, a much smaller, dimmer version of itself. Not quite as dramatic as a neutron star, right? But let's play along and imagine some crazy cosmic event, like a collision with a massive star, suddenly compresses our sun into a neutron star. What would happen next? Immediate changes in the solar system. First off, the sun's size would shrink from its current diameter of 1.4 million kilometers to just about 20 kilometers. That's smaller than most cities. But here's the twist. The sun's mass would remain the same. That means its gravitational pull on the planets wouldn't change. Earth, along with the other planets, would continue orbiting the neutron star along the same paths, at least initially. However, the sun would no longer produce light or heat, and that, my friends, is where the real trouble begins. What happens to Earth? 1. Loss of light and heat. The sun is our primary source of energy. Without its heat, Earth would quickly become a frozen wasteland. Within a week, temperatures would plummet to around minus 70 degrees. Within a year, the oceans would freeze solid, starting from the surface and eventually becoming ice blocks several kilometers thick. Life on the surface would be impossible. Plants would die first, followed by animals that depend on them. Without sunlight, photosynthesis stops and the food chain collapses. 2. Atmospheric changes. Our atmosphere would also freeze and collapse over time. The nitrogen and oxygen we breathe would condense into liquid and eventually freeze onto the planet's surface. Earth would become a cold, airless rock. 3. Radiation danger. But freezing isn't the only problem. Neutron stars emit deadly radiation, including X-rays and gamma rays. Even with our atmosphere intact for a while, this radiation could strip away what's left, exposing Earth to even more cosmic rays. Could humans survive? So, could humans survive in this apocalyptic scenario? Well, maybe, but it wouldn't be easy. We'd need to build underground cities, complete with artificial lighting and heating systems powered by geothermal or nuclear energy. Food would come from hydroponic farms or lab-grown meat. We'd also need heavy shielding to protect ourselves from radiation. Humanity could hang on for a while, but it would be a constant struggle for survival. And let's be real, most species on Earth wouldn't make it. What happens to the rest of the solar system? The entire solar system would be thrown into chaos. Without the sun's heat, planets like Venus, Mars, and even gas giants like Jupiter would freeze. Their atmospheres would collapse, just like Earth's. But there's an interesting twist. Some of Jupiter's moons, like Europa and Ganymede, might still harbor subsurface oceans thanks to their internal heating caused by tidal forces. These icy moons could become humanity's last hope for finding liquid water in the solar system. Is there any good news? Okay, let's try to find a silver lining. For one, without solar flares and coronal mass ejections, we wouldn't have to worry about geomagnetic storms frying our satellites and power grids. Technology. But let's be honest, any positives are completely overshadowed by the freezing temperatures and deadly radiation. Final thoughts. The good news is, we don't need to lose sleep over this scenario. Our sun is too small to ever become a neutron star. Instead, it'll live out its life as a white dwarf billions of years from now. No freezing apocalypse, no deadly radiation. But imagining these scenarios reminds us how fragile life is and how much we depend on our sun. So the next time you're outside, soaking up the sunlight, take a moment to appreciate our star. It's doing an amazing job keeping us alive. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more science facts. See you next time on Science Unveiled.